The null hypothesis is HO, and it is what the researchers are trying to nullify. There is no statistical difference between both of the hypotheses, and it is what the researcher is trying to disapprove. So an example would be that the null is that the world is flat, but the alternative would be that the world is round. Another would be a person is trying to figure out if the different waters would affect plants, but the researcher is trying to nullify it and say that it does affect it.
So you can't ever accept the null hypothesis because just because something is proven false does not mean it is true. There's not sufficient evidence to reject it, but it doesn't mean we can accept it.
The alternate hypothesis is a position that states a new idea, and this idea contradicts the null hypothesis. We determine whether to accept or reject the alternate hypothesis, and an example of this would be if the null hypothesis would be I am going to win $1,000. The alternate hypothesis would be I'm going to win more than $1,000.
After you make a conclusion about your null and alternate hypothesis, you can make an error. You can either make a type 1 or type 2 error. A type 1 error was that you rejected your null hypothesis when you shouldn't have. The null hypothesis was true, but due to a sample discrepancy, your results were affected and you rejected the null when you shouldn't have.
Alpha levels. Alpha level is the probability of making the wrong decision when alpha levels. Alpha level is the probability of making the wrong decision when the null hypothesis is known as alpha level. There are different parts to this. There's a critical region, also known as the rejection area, and it is part of the testing process too. It is a probability that tells you if your theory is probably true. There's type 1 error, which is supporting the alternative hypothesis when the null hypothesis isn't true. For type 2 error, not supporting the alternative hypothesis when the alternative hypothesis is true. So when you change your alpha level from 0.01 to 0.05, you increase your chances of accepting H1. You as a researcher, you choose the alpha level you're willing to accept. For example, if you wanted to have a 95% confidence that your results are significant, you choose the 5% alpha level. And you get that by 100 subtracting 95%, which equals 75%. Tail test, you divide 5% by 2, so each tail has a critical region.
So I'm doing the critical region, and the critical region is basically the area of extreme values. If you have a two-tailed graph, there's going to be one on this side and one on this side. If it's just one-tailed, it's going to be the most extreme values. And the critical region has the values, which are all of the values that would cause a rejection of the null hypothesis. So they're very different from the rest, or unlikely from the other values. So this is a two-tailed, so there's a critical region right here and another one right here, which is the rejection region and rejection region. If this was just a one-tailed, then it would just be on this side or on this side, not both.